Well, hello. It is the Monaco here. Our 8th homework lecture in atomic theory. We're going to start drawing some models of atoms. We're going to start with the Bohr models of the atoms, which include the orbitals and the nucleus. And our objective here is to learn how to make simple models of atoms from the information provided on the periodic table. You'll have a Google Classroom assignment to follow this up. So why will we construct the model of the atom? Well, it serves as a map. It shows us the nucleus, the energy levels, and the electrons in each level. So it just gives us a nice picture of what this information in the periodic table square actually means. To make a Bohr model of the atom, the first thing we got to do is kind of like, draw a small circle for the nucleus. To identify that nucleus, we need to fill in the number of protons and neutrons. Well, from this particular example, the protons are 6, and the neutrons are 6 as well. I figured out that from the atomic mass and the atomic number that's presented. To draw in the energy levels, we got to draw a circle around the nucleus for each energy level in the atom, and that's presented by the electron configuration. This shows that there's 2 circles or energy levels. In reality, they're much more complex than that, but this is a very simple model of the atom. So each number represents an energy level. Tells on me circles to draw. So assigning electrons to the energy level. So let me just redraw this little picture here. Protons, neutrons, and 2 energy levels, using our carbon example. So I need to assign electrons to the energy levels. So the first number in the electron configuration represents the energy level closest to the nucleus. That's the first ring. That's the second ring. So the first ring shows me that I have 2 electrons in there. I separate them. I place them opposite. It's visually easy to see. And let's see what else. Guess what happens next? I bet we put the, electrons each to the energy level from there. So the first ring got 2. That means the second ring is going to get 4. Spread them out at the clock positions. Go 12, 3, 6, 9, etc., etc., and then fill in the gaps as we go. So atoms versus ions. The nucleus of an atom is corresponding ion will be the same. So if I have to do an ion, like a carbon -4, the nucleus is going to be the same protons, same neutrons. The number of energy levels and electrons will change based on if the ion gained or lost electrons. So if I wanted to do the carbon ion, so this was the atom, I drew the carbon atom, but if I want to do the carbon -4 ion, I would have to add 4 more electrons to the outside ring, which means because it picks up 4 more. Now it's no longer an atom, but it's an ion with an overall charge of -4, and we'd place that in the top right corner. So the nucleus doesn't change, but the valence shell of electrons grows or shrinks depending on what type of ion is formed. So if the ion loses all of its valence electrons, there's no need to draw the empty energy level. Let me show you the +4 ion and how we would draw that. Okay, let me start over a little bit. Okay, so if the +4 if we're going to do this ion, it means that we have lost 4 electrons from the outside ring, which means that entire ring disappears, which means that there is, right there, a carbon +4 ion. We don't need to draw an empty ring of electrons because it simply just goes away. Here's an example. I did an example for you. Let me do another one really easy for you. That carbon we did many times. So we got 6 protons, 6 neutrons. You could do this all in one color, or you can color code it. I encourage color coding, like I did in the previous example. To do a lithium ion Bohr model, well, the lithium ion is a +1. and which means it's lost one electron. So if I look at the periodic table, I see lithium's got 3 protons and 4 neutrons. And if I've lost one electron from lithium, it means I no longer have 2 rings of electrons, but I only have 1. So I'm going to put 1 ring of electrons with 2 electrons on it. And I'm going to show that it's an ion by putting it in brackets and putting a +1 up to the right outside the brackets. A fluorine ion. Well, fluorine's on the other side of the periodic table. It's a bit bigger than lithium. It's got, let's see, 9 protons and 10 neutrons. And typically it's got 2 rings of electrons. And the fluorine ion is fluorine -1, meaning it's picked up 1 more electron than it normally has. So instead of 2-7 for my electron configuration, I'm going to do 2-8, adding in that 1 more electron to the outside valence shell. And I will give it a -1 overall charge. And that is drawing Bohr models. We are going to do a bunch of it. So your Google Classroom assignment is a follow-up, of course. Make sure that you submit that, and we're going to do a few pages of practice on this stuff so we really get a good handle on making maps of atoms from the periodic table. Thanks for watching and paying attention.